Hey, so I thought I would give you an example or two of some of those quadratic word problems. I noticed in ALEKS, some of you had trouble finishing this section. It is probably the last section in Unit 4, Quadratics. And if you didn't get to this section, or you couldn't figure it out, it is now called Open Pie Mode, and you have a 10 topics review assignment, and you can do this topic again and hopefully complete it this time, or you can pick other topics to do, but at some point you'll need to figure out how to do this topic. So I thought I could explain a couple problems and hopefully that will help you. So this first one that I took directly from ALEKS says Jane has 320 meters of fencing, wishes to form 3 sides of a rectangular field. The 4th side's a river, no fencing. Okay, and then they do give you that this side they want to call X. So hopefully we also know that this side would be X, right? And we don't actually know the length of this side, so I'm just going to call it Y, because I don't know what it is. I don't want to put a Y over here because I only want to have the 3 sides of the fence. Okay, so it says that she has 320 meters of fencing. So you want to think, okay, that's the distance around. That's called the perimeter, right? So the perimeter of these 3 sides would be x plus x, making 2x, and then plus y, just one y, and that would equal the 320 meters. Right? Now, that is not the answer to part A, right? Because they say give a function of area, but it is what we're given in the problem, right? So we have to start with what we're given, and then we figure out how to apply that to the problem. So in order to use this equation, if you notice in part A, it says that we want to have the area in terms of x, right? So notice in this equation, which is the perimeter equation, we have an x and a y. So what we want to do first is solve for this y. Okay, so if we solve for the y, we subtract 2x from both sides. That would be 320 minus 2x. Okay, we're going to use that in our part A. All right, so for part A, it says find a function that gives the area in terms of x. So hopefully you know that the area of a rectangle is just the base times the height. Okay, and in this case, we have the area base times height. Okay, and then notice that in this problem, the base is y and the height is x. So y times x or x times y is the same thing. Okay, now that also is not our answer because we cannot use y in there. We have to only use x's. So here's where we're going to substitute in. So for this y, we're going to substitute in this value for the y. And doing that gives us area equals 320 minus 2x times another x. Okay, so then they probably will want you to multiply this out to simplify it a little bit. So our area equals 320 x, distributing that x, multiplying it to the 320, and then minus 2x squared. Okay, that x looks a little funny. It's going to bother me, so let's fix that. 320x. Okay, so this is what we want to put over here. We can put it in this order, or we can reverse the order because notice that the x squared term could come first, but ALEKS will accept either answer in this case. So 320x minus 2x squared. Okay, so now let's take a look at part B. And this is going to be really representative of all these problems. Let me just pull this down a little more for you guys. Too far, too far. Oh dear. See, I really want to see the area. Okay, there we go. Perfect. So this is a very, very typical problem in ALEKS and in your textbook. So, I think if you understand this one, you'll be able to do a lot of these. Okay, so it says what side length gives the maximum area? Okay, and notice it's maximum area. So this function that we have right here, that's the area function. We need to think about where the max would be, right? Or what's the max called? right? So this function is a quadratic, right? Or a parabola. And notice that it's minus 2x squared, so it's actually going to be facing downwards. And so the maximum is right here. And hopefully we know that that max is called the vertex. Okay, so if we're supposed to find the vertex, we know a method for finding the vertex using this form, right? And that is h equals negative b over 2a. Okay, and that's the x coordinate of the vertex. So the max, the vertex is going to be h comma k. Okay, all right, so negative b over 2a. So in this case, with this function, just be really careful because the b value is the 320. So I'm just going to write down the a value and the b value first because they are switched. So the a value is the negative 2. It's whatever goes with the x squared term. And the b value is the positive 320. Okay, so h is equal to negative 320 divided by 2 times negative 2. So notice it's a negative divided by a negative, so it's a positive, and it's 320 divided by 4. So I think that's 80, right? Yep. So we're getting 80, and that is our answer for the x coordinate, right? So it says what side length x gives the maximum area the field can have, and so that x is 80 meters. And then you can see in part C, this is typically the other thing they will ask, what is the maximum area? Okay, well that is the k value, the area function, right, with the 80 plugged in. So the k value, which is the area function with 80 plugged in. Okay, and so that would be your, make sure it's still on the screen. Yep, 320 times 80 minus 2 times 80 squared. Okay, I have to admit I didn't actually figure that out, so let me just pull up my calculator and do that. Okay, I'm just gonna, just type it into my calculator. I could probably put that on the screen. Hold on. Oh, hello, calculator. How are you? Okay, so let me clear what I have. Okay, and then just put 320 times 80 minus 2 times 80 squared. Okay, so use your parentheses, use the squared button if you want to. Probably the easiest way to go, or it's 80 times 80. So I got 12,800. Let me get that calculator off the screen. Bye-bye, calculator. And we get 12,800. Okay, and that was, the sides were in meters, so this would be meters squared. So our answer here would be 12,800 meters squared. Okay, I'm going to do a separate video for another problem so you can have two nice examples of this, but hopefully that was helpful.